Hi guys, I know I'm not with you today. Again, I'm really sorry about that, but I'm going to help you through these notes with this video. So you should be following along, pausing whenever you need to, that type of thing. So let's look at the first equation. X squared plus 4x plus 4 equals 5. And I've asked you to try to solve it by factoring. So we know that we have to get it set equal to 0 first, which means we would take away 5 from both sides. So we would have x squared plus 4x minus 1 equals 0. And our goal is to use the zero product property, so now we factor that left side. Well, taking 1, our leading coefficient, times -1, our constant, we get -1, and we would need factors of -1 that add up to that b term, that 4. And we know the factors of -1 are 1 and -1. That's the only possibility, which clearly when I add those it doesn't equal 4. So in this case we actually cannot solve this particular quadratic by factoring. That doesn't mean necessarily that it cannot be solved, it just means that it cannot be solved by factoring. Could we solve the equation by square roots? That's our next question. Why or why not? Well, hopefully you remember that one of the rules for solving by square roots is if it's in standard form, you cannot have a b term. But if we look at it, we have the x squared plus 4x plus 4 equals 5. The fact is we have this term right here, that plus 4x. That's our b term. So the answer here is no, we can't use square roots. It's not in vertex form, it's in standard form, and it has a b term, right? So it has a b term. That's why we can't solve it by square roots. So does this mean that there's no solution? No, it doesn't mean that there's no solution. It just means that both factoring and square roots didn't work. We could graph it, but I want to see another algebraic way to go through and actually solve this. And that's where the term complete the square is going to come into play. And so I want you to just kind of look through this example that I have on your notes. It's still x squared plus 4x plus 4 equals 5, and you'll notice what I end up doing here, and I'll kind of highlight around this. I factored the left side, and I went ahead and I factored it without moving that 5 over. So you'll notice I kept the 5 over here, and just this side, just this left side, I went ahead and I factored by splitting the middle. So the 1x squared and the 4, I took the 1 times the 4, right, and I got 4, and the factors of 4 that add up to 4 were 2 and 2. So I split that middle term into 2x and 2x. And then out of that first group I factored out an x and had x plus 2. Out of the second group I factored out a positive 2. So it ends up factoring to be x plus 2 times x plus 2. Well, if I want to, I could rewrite that as x plus 2 the quantity squared. And that's what I did here in that last step. And if you notice, now that we have x plus 2 the quantity squared equals 5, now this is essentially in what we've been calling vertex form, right? It's a quantity squared equaling another number. And so in this form, we can solve it by square roots. In fact, if I wanted to, I can have some room down here, and on your notes you should be following along. If we have the quantity x plus 2 squared equals 5, we can solve this by square rooting both sides. And remember, when we square root both sides, because that squared quantity is already by itself, so we can square root both sides, and we take that positive and negative square root. So on the left side we have x plus 2, and on the right side we have a positive and negative, and you might want to grab your calculator, plug this in, and you should get 2.24. Okay, so that means to get x by itself now, we want to take away 2 from both sides. So our final answer, x equals positive or negative 2.24 minus 2. So that means we have two situations here. We have a positive 2.24 minus 2, and then we also have negative 2.24 minus 2. Positive 2.24 minus 2 will give us 0.24, so that's one answer. And negative 2.24 minus 2 is negative 4.24. So we were able to finally come up with two solutions to that quadratic, and the whole point was we basically went from standard form and we created a vertex form of that same equation. And that's essentially what completing the square is. Now it's a little bit more intense than that. Here soon you'll see more examples where you have to do a little bit more. I don't give you exactly what you need at the beginning, but just to start off, I want you to go through the next questions in the exact same way. I want you to factor the left side, keep the other constant that it's equal to on the right side, just keep that where it is. Factor the left side, and it should factor into a quantity squared, and that way you can continue to solve by square roots. So go ahead, pause the video, and take a look at that next problem on the back. There's a few of those. Go ahead and look at this first one, x squared plus 10x plus 25 equals 7. Go ahead, take care of that, and then come back and check to see how you did. So on this one, hopefully after you factored it, you recognize that it factored to be x plus 5 times x plus 5 equals 7. So that means really what you had there was x plus 5, the quantity squared, equals 7. Alright, and now we can see that we could solve the rest of this by square roots. So we square root both sides. We get x plus 5 equals positive or negative 2.65. So then we have to take away 5 from both sides. So our final answers here, when we do positive 2.65 and we subtract 5, we're going to get negative 2.35. And this, again, we're just rounding to the nearest hundredth. It's kind of up to you, or I would give you that hint if I needed you to round differently. But then negative 2.65 minus 5 is going to be negative 7.65. So those would be our two answers here. Again, go through, try each of these. I'm going to pause my video, write in the answers, and then I'll go ahead and just reveal all of the next ones to you at once. But I want you to try them all on your own first before watching the rest of this. Okay, go ahead and check the next 3 problems. So I'll kind of run through them quickly. On that first one, you should have had it factored to be x plus 7, the quantity squared, equals 3. And then your solutions ended up being about negative 5.27 and negative 8.73. Pause it, check yours. Hopefully you can follow my steps there if anything went wrong. The next one factored down here to x plus 9, the quantity squared, equals 13. And then when we go ahead and solve it, you get x equals negative 5.39 and negative 12.61. And then the last one, x plus 11, the quantity squared, equals 14. Solving that by square roots, you should get negative 7.26 and negative 14.74. Now before I go on to the last part of this paper, I want you to go back to the front. So I'm on the front here, and I want to look back at that original problem, that x squared plus 4x plus 4, and how it ended up factoring to be that x plus 2 quantity squared. Think about x squared plus 4x plus 4. Think about that expression with algebra tiles. Remember, the x squared was the large square tile, and then there are 4 x tiles. So those were the smaller rectangular tiles. So 1, 2, and then I'm going to put 2 more down here. 3, 4. And if you notice that plus 4, the 4 1 tiles perfectly fit right here. And all of a sudden I have a square, right? This entire shape here is a perfect square. And this side up here is x plus 1 from this side and 1 from this side, so x plus 2. And this side over here is x plus 1 plus 1, so this over here is also x plus 2. So it ends up being a square that is x plus 2 by x plus 2. Wasn't that exactly how it factored? X plus 2, the quantity squared. That actually happens with all of these on the back side. You know, the x squared plus 10x plus 25. Well, if you actually looked at that, let's see, I can try to zoom out and find some space there. The x squared plus 10x plus 25, picture that with algebra tiles. X squared, so the large x, And then, try to do this quickly, you have 1, 2, 3, 4, 5 of the x tiles here, and 5 of them on this side. Obviously mine are not going to be perfectly drawn to scale. But there's your x squared and 10 x's. Well, I can see that I would have 1, 2, 3, I could just kind of quickly draw them in. There's going to be 5 rows of 5 1 tiles, which means 25 tiles fit directly right in there. And this would be a square. And that square ends up being, if I kind of count the side lengths, remember this has a side length of x, and then each of these little ones are 1. So up here this is x plus 5, and I have the same thing on the side. X on this side plus 1, 2, 3, 4, 5. So this side is also x plus 5. That's why that left side of the equation factored to be x plus 5, the quantity squared. Okay, so all of these I gave them to you because they worked out that way. They work out perfectly. They are perfect squares. Okay, that's why we got that quantity squared. I'm going to erase this now, and let's look at that last little part on the bottom of the back of your page, and we'll talk more about this together tomorrow, but hopefully really try to understand this on your own a little bit. Okay. It says all the problems on this worksheet worked out perfectly because we were able to factor the left side to be a squared quantity, right? They are perfect squares when we build them with algebra tiles. But we know that most quadratics don't factor that way, right? Everything that we factored, it's really rare that the two factors were the exact same. So that's not that common. So what are we going to do when that doesn't work out? So think about x squared plus 12x. What would that look like? Well, if I built that with algebra tiles, x squared, we would have our large x tile, or I'm sorry, x squared tile. The 12 x's, think about how I did all of these other ones. I kind of split up like on that front. It had 4 x's, and I put 2 here and 2 over here facing kind of the other direction. So I'm going to split up the 12 x's, and I'm going to put 6 on one side. So 1, 2, 3, 4, 5, and 6. And I'm going to do the same thing here. 1, 2, 3, 4, 5, and 6. Clearly my horizontal ones aren't as good. So this is not a complete square, right? I have all of this space down here that is empty right now. What am I going to be putting to fill in that space? Well, it's going to be filled with 1 tiles, and how many of them are there going to be? Well, I could fit 1, 2, 3, 4, 5, 6 in a row, right? And there would be 6 rows of those. So without drawing them all, 6 by 6, 1, 2, 3, 4, 5, 6 rows of 6, 2, 3, 4, 5, 6, I'm going to have 36 tiles there. So if I wanted to, I could add 36 in this expression, and all of a sudden this would be something that I can factor. And judging by the length of each side here, this is x plus 1, 2, 3, 4, 5, 6. So this is x plus 6, and this is x plus 1, 2, 3, 4, 5, 6, so x plus 6. It's x plus 6, the quantity squared. Now the only thing here is, if I added 36 to this side of the equation, I have to add 36 to this side. So now my equation is actually x plus 6, the quantity squared, equals 46. And now I can solve that. So if I'm going to solve x plus 6, the quantity squared, equals 46, I can square root both sides. So we would have x plus 6 equals positive or negative 6.78. We take away 6 from both sides. So a positive 6.78 minus 6 is going to be 0.78. And a negative 6.78 minus 6 is negative 12.78. And those are our two solutions. So this is true completing the square. We physically completed a square here. Whatever we added to one side, we add to the other, and then it's a matter of solving by square roots. So this is what we're going to continue doing tomorrow and into next week.